It's so close. It's beautiful.
Welcome back to the workshop, everyone. Glad you could join us again for part 7 of our Tube Preamp Pedal Build. Last week was a really good week. We got a lot of stuff done. We got the whole switching circuit board installed, wired up, got all the ground wires terminated, some of the shielded cables and the mechanical switches wired up. However, I did find kind of a big problem that I had to fix. And I wasn't able to do any recording yesterday because I spent most of the day fixing a mistake. I mentioned in one of the earlier videos that because the power supply for the relay on the input board didn't need to be well regulated, I was just going to use a Zener diode as a regulator. Well, I knew that Zeners were not very efficient regulators. I didn't realize just how bad they were. The filament winding is rated for 1.05 amps. And when I measured the current on the filament winding, which was also powering our relay, it was drawing 1.1 amps. So it was slightly overloading the transformer. Now that amount of overload isn't going to kill the transformer. However, that was without the relay even being engaged. So I could have ended up burning up the transformer if I hadn't changed that. Also, the fuse almost blew. The reason I can tell that it almost blew was because of the discoloration on the fuse. It's the fuse on the right. You can see there it got really hot. I think if I had been drawing any more current, it would have blown. So what I had to do was take out this input board with the, and there's, you know, this one's got the input buffer and the relay, and then this one was the boost stage. I took that out and I built a new one. The new one, I think, not only looks a little bit cleaner, but it fits a little bit better in that space. So I'm kind of glad that I had to do that because I wasn't real satisfied with the way that the old input board looked. But because I couldn't use a relay anymore, I changed one of the stomp switches to a triple pole double throw switch. So now it's using mechanical switching for the bypass, which is not a big deal, but it also meant that I had to run a bunch more shielded cable from the jack down to the switch and then back up, and so that took some time to do that. Another change I had to make was switching out some of the 2N5088 transistor switches on the switching board from MOSFETs. These are the 3 switches that were used for the boost function. There's one per channel, one for the lead channel, one for the rhythm channel, and then one underneath it that turns the boost on or off regardless of what channel you're on. And I had to replace those with a MOSFET. The 2N5088s had a higher on resistance than I expected. I thought it was going to be about 20 ohms. It ended up being, it was something like 250 ohms total series resistance going through 2 of those switches. Now it didn't occur to me at the time, otherwise I would have measured the voltages here, but it's possible that because of the resistance of this lower transistor, it was actually elevating the voltages on this upper transistor so that the base couldn't be pulled high enough to make this transistor fully conduct. So that may have been contributing to the high series resistance here. I'm not sure. So I replaced them with MOSFETs, and now it's down to about 50 ohms total. So that'll allow us to get a little bit more boost than we would have had available if I had left those bipolar transistors in there. Here's the circuit that I had been using to regulate the voltage for the relay. Our filament supply comes in here, gets rectified, there's a smoothing capacitor, and then it hits a small value resistor and our Zener, which is a 5.1 volt Zener. And it does a fairly good job of producing a stable 5.1 volt output from there, which was low enough that it wasn't going to damage the coil on the relay, and that's what I was concerned about. It didn't have to be well regulated, I just needed to make sure that, you know, if 7.5 volts is probably enough to burn up the coil on a 5-volt relay, especially with prolonged use. I knew that I was going to lose a little bit of current by using a Zener, but it depends on how much current you're drawing. That relay was only drawing about 28 milliamps, and the transistor switches that were also being powered off that same leg were only drawing a few milliamps total. So I didn't think it was going to be a big deal. It turns out it was throwing away over 100 milliamps. And when you're that close to the design spec for that winding on the transformer, 100 milliamps makes a big difference. I expected this to be, maybe 50% efficient. It was closer to 5% efficient. So right now, all of the LEDs and transistor switches are being supplied from this, just a bridge rectifier and a capacitor, and it's given me somewhere around 7.5 volts. So anyway, I did a lot of tedious and frustrating work yesterday. Everything has felt like 2 steps forward, 1 step back. But when you're working on a brand new design like this, that just kind of goes with the territory. If you're going to get into something like this, especially a project that's this elaborate, this is not, I'm not building a simple stomp box here. There's a lot of stuff going on inside here. You have to be prepared to overcome some obstacles, and just know that, it's okay to be frustrated. It's not okay to give up, because you will eventually figure it out, and I have had more than my share of frustration over the years over projects like this. You jump into the deep end, and by the time you've finished, you're walking away with knowledge that you didn't have going in. So, you're never going to learn more about something by doing something that you're already comfortable with and you already know you can do. So, as frustrating as yesterday was, this is how we learn. So now that we've got those issues sorted out, we're going to go through and finally, I was supposed to do this in the last video, but I just ran out of time. So this time, we're finally going to test all of our switching points and make sure that all the transistor switches are working properly. Alright, once again, I've just got a tone setting on my multimeter. No, I don't. Now I do. So we'll switch this on, and our boost is on now. Make sure that these boost pots are both turned all the way up. This one should be open, which it is. And now if we switch channels, now that one's conducting. And if we turn the boost off, that works. Okay, so those ones are all working properly. This is the spot in the circuit that is going to be grounded out when we bypass this pedal. This is going to be a little tougher to get to, so I'm going to grab a different probe. Okay, so I should not be getting a tone now, but when I bypass the pedal... Okay, so that's working too. Alright, so now we are finally ready to start soldering in some of the good stuff. I forgot to mention earlier, when I got rid of that Zener regulator, it dropped the current draw on the filament winding down to, I want to say it was like 950 milliamps, so below the rating for the transformer. So we're definitely in a much safer place now. So let's start wiring up the preamp. Alright, the top half of these terminal strips is done, and I'm going to slow down for a bit and just take some time to look over everything, make sure I haven't connected anything in the wrong spot. I caught myself a couple of times connecting things to the wrong terminal and then went back and fixed it. But one of the things about this construction method is if you get too far into it, it ends up being really difficult to change anything because these components are straddling the tube sockets, so there's stuff going on underneath all these components that I need to be able to get to if I'm going to fix a mistake. I've never built anything this way before. Normally I'll have the circuit board, you know, down here and then the tube sockets off to the side like you'd see in almost every amplifier. And you would think that being so close to the tube sockets like this, you'd have some issues with oscillation just because everything's so close together. But I don't think I'm going to have any issues with that. Okay, they built this thing using that same method. I love looking at these old Tektronix scopes because they're just a work of art. It's amazing the way they put these things together. You can tell that they put a lot of thought into the quality of their products. I've got a newer one, a 1960s, a late 1960s scope, and it's the same way. Just the build quality is absolutely amazing, and it's no wonder these things last for so long. But here's the, so they've got some of these ceramic terminal strips here, and they're doing the same thing. They're going across here, and then the tube sockets are down underneath. Now these are very sensitive circuits. They're designed to be sensitive. So if they can build this without having any oscillation problems and put everything in so close to the tube sockets without any issues, then there shouldn't be any problem with this preamp. And there's all the tubes underneath there. Okay, I spent some time looking over this, and I only found one mistake. The first coupling capacitor that I put in here was a .0022. It was supposed to be a .022, so I switched that out. So let's keep going. Okay, the entire preamp is now installed. Everything's wired up. The only thing that hasn't been installed yet is the speaker emulator board, which we'll work on later. It's definitely not the prettiest build I've ever done, but you know, the important thing is whether or not it works. And we're going to test that next time. Unfortunately, I've run out of time again this week. When I do these videos, there's an awful lot of time that has to be spent on editing. Otherwise, you'd end up watching a 3-hour video in real time of me doing all the soldering, and that's, you know, nobody wants to watch that. So, I've got to have time to edit this so I can get it posted. But when we come back in the next video, we're going to retest the power supply voltages, mostly because I'm just curious to see how much they dropped now that we've got the tubes wired up. And then we'll fire it up and see if we get any noise out of it. I'm going to have to work out some way of testing this through a power amp. None of the amplifiers that I have here at the workshop have an effects loop in them. And ideally I would want to run this into the return jack of an effects loop. Every amplifier is going to have a certain amount of tone shaping in it, especially if it's got a bass, middle, and treble control. So you end up getting a little bit of a mid scoop in there. Well, this has its own mid scoop built in because it's got a bass, middle, and treble control. So those EQ curves would add together and you'd end up with a really severe mid scoop. And so I really need to run it into something with a flat frequency response. So I'll have to work on that. Maybe I'll borrow an amplifier for someone just to bring in here for testing purposes. So that's it for today. Thanks for watching. Like it if you like it, comment, and subscribe, and we'll see you in the next video when we finally get to fire this thing up.